In this video, we are going to review some problems that you may not have seen before, some unique problem types that are helpful to see before you encounter them on a test. Here we have Alvin comparing the cost of music downloads from 3 different websites. And we can see that the trick here is that they've presented us this information from each website in 3 different ways. First, we have a table. We can take this table and we can find out the cost per download. So it costs $4.50 and we get 3 downloads. That is $1.50 per download. We could do that with a $7.50 and 5, or we could do it with $10.50 and 7, but we're going to get the same $1.50 each time. Let's go over to the Song Factory. This one looks pretty straightforward. We get $14, or it costs us $14, and we get 8. And we do that division, and we get $1.75 per download. Finally, we have this chart in the middle. And the cost per download on this chart is actually going to be the slope. So we can find the slope of this line by going from this point to this point. We go up $2 and we go over 1. It's $2 per 1 download. We could also get that by noting, say, one of the points on the line. 3 downloads cost $6. So 6 divided by 3 is $2. So we have to put these in order. We look at the 3 numbers. $1.50 is the lowest price. $1.75 is next. And finally, this one is the most expensive. So Music Mania, then Song Factory, then Song Central. Let's look at the next problem. Angles of a triangle are in the ratio of 5 to 9 to 14. What is the measure of the largest angle? This is a very confusing problem. If you haven't seen it before, let me try to draw a triangle. Maybe our triangle looks like that. And let's put these numbers in each corner. I'm going to put 14 up here because that seems like the biggest one. And we'll put 9 over here, and we'll put 5 here. It's not important that our triangle look perfect. We just want to have 3 corners to put those numbers. Now I'm going to do something that might not be so obvious. I'm going to add an x to each one of those. X as a variable. Now that I've done that, I can say that the sum of 14x plus 9x plus 5x must be equal to what? The sum of the angles in a triangle have to be equal to 180. So we can combine these like terms. We have 14x's and 9x's and 5 more x's. That is a total of 28 x's, and that equals 180. And then let's divide both sides by 28. You might be wondering, where are we going here? What is x? Well, x is just a multiplier that's going to help us figure out what those angles are. So if you divided that out, you might get 6.428. And if we take that number and we multiply it by 14, we should get our largest angle. We'll get something very close to our largest angle. Because of the rounding, we might not get exactly the right number. In fact, I get 89.99. Well, guess which angle that is? That is 90, and that's our answer. We could check these others. 5 times 6.428, that's about 32. And 9 times 6.428, that's about 58. And that's how we can find out the angles inside of a triangle when we are given a ratio. Now, this may not look like a traditional ratio to you because of the 2 sets of colons, but that just is a 3-part ratio. Okay, next problem. What is the average rate of change of the function g of x from x equals 3 to x equals y? Now, I want you to remember that in function notation, it might be easier to think of g of x as simply y. So when x is 0, y is 34. When x is 3, y is 30. These are just points on a graph. We can find the average rate of change the same way that we find slope. So we want to take our 2 points here, when x equals 3 and when x equals 11, and treat those like 2 points, 3, 30, and 11, 16. And then use our slope formula. M is equal to y2 minus y1, a little bit of review here, x2 minus x1, and then we plug in our values. Y2 is 16, and we're going to subtract 30, and x2 is 11, and we're going to subtract 3. So we get 16 minus 30, which is minus 14, 11 minus 3, which is 8, and we divide negative 14 by 8, and we get negative 1.75. So that is just like a slope. Our average rate of change is negative 1.75. Very confusing if you haven't seen that problem before. Jeremy has a weekend job as a soccer referee. On one weekend, he earns $140 by working 4 games. Another weekend, he earns $210 by working 6 games. If Jeremy graphed an equation that would represent his total earnings based on the games worked, what would be the slope of the graph? Now, even though these are bigger numbers, it's kind of the same thing as the previous problem. These are 2 points on a graph. We want to treat the games he works as x and the dollars that he earns as y. That's because the games is the input. He works a certain number of games, and by working those games, he gets his output, which is the dollars that he earns. So if we were to make a graph, we would maybe make it like this, and we would say games, and we would say earnings. And on the earnings, that would be dollars. So just to crudely make a graph, 1, 2, 3, 4, 5, 6. And over here, we're going to have to do this a little differently. 50, 100, 150, 200, 250. So 50, 100, 150, 200, 250. So let me plot a few points there crudely. 4 games, 1, 2, 3, 4. He was going to make a little bit less than $150. 6 games, he's going to make a little bit more than $200. So now you can see that our line, if I tried to draw one, might look like this. And we are trying to figure out the slope of that. The easiest way to figure out the slope is to use the slope formula. And the coordinate for this point is 4 games, $140. And the coordinate for this point is 6 games, $210. Now we can use our slope formula. Let's treat this as x1, y1, x2, y2. 140 minus 210 over 4 minus 6. I probably should have done it the other way, but it will still work. 140 minus 210 is minus 70. And 4 minus 6 is minus 2. And we divide and we get a slope of 35. And what that means in this case is that he makes $35 per game. And you might have looked at these numbers here and said, well, I could have got that by just dividing 140 by 4. I'd get 35. I could have divided 210 by 6, and you could get 35. And that is true in this particular case. That will definitely work. Angles inside of a circle. What is the innermost angle of one slice of the pizza? So it's helpful to know for this problem the total number of degrees in a circle. If we go all of the way around a circle, how many degrees is that? That is 360 degrees. So now we just have to divide that up into the number of pieces. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 pieces. 360 divided by 8 is 45 degrees. So one slice, which is what this question is asking about, the innermost angle of one slice of pizza is 45 degrees. In this case, because there are 8 pieces. If there were 6 pieces, it would be a different number. There would be 360 divided by 6 equals 60 degrees. So that solving that problem depends on remembering that there are 360 degrees in a circle. The square root of 129 is between which numbers? Well, let's remember that when we're taking the square root, we're trying to find out what number times itself is going to give us this number. But we can't figure that out without a calculator. And this is the kind of problem that you would probably have to do without a calculator. So let's go through some of the squares. I'm going to start at 5. 5 squared is 25. 6 squared is 36. That's a better 36. 7 squared is 49. 8 squared, we might have started out a little too low, 64. 9 squared is 81. We're starting to get closer to that 129. 10 squared is 100. 11 squared is 121. And 12 squared is 144. See how we have now passed that number. 129 is in between 121 and 144. That means that the square root of 129 must be between 11 and 12. That's how you figure out approximately what a square root must be. It must be in between those square roots that you know. We know that the square root, to state this another way, of 121 is 11. We know that the square root of 144 is 12. So the square root of 129 must be in between those two. We don't know exactly what it is, just that it's between 11 and 12. Next problem. A dot plot is based on the table above. However, it is incomplete. Place the dots on the dot plot until it accurately reflects the records over an 8-week period. So we are collecting the number of advertisements received. Each dot on this plot is a week in this chart. Notice that there are 8 weeks. There should be 8 dots on our plot. Therefore, we're missing 4. That's important because we want to make sure that we end up with 8. So let's start by checking if there's anything below 3, because we don't have any dots on 1 or 2. And we go down the list here and we find that in the 8th week, there were 2 advertisements received. That means we need to add a dot at 2. Now let's check whether we have the right number on 3. Is there only 1 week where there were 3? Yes, it looks like that is correct. We're not missing anything there. How about 4? We only have 1 dot on 4. I see a 4 here, and here, and here. There are 3 4s. So we better add 2 more dots. Let's check 5. Yes, there's only 1 5. How about 6? There's only 1 6. And 7, we do not have a dot for 7. And it looks like we now have them all accounted for. Do we have 8 dots? 1, 2, 3, 4, 5, 6, 7, 8. Yes, we do. That's all there is to that. We're completing a dot plot by comparing it to the data. Which of the following is a graph of this inequality? You may or may not have seen this kind of inequality where x is in between 2 different numbers. What that means is that we are talking about a graph where we are between 2 numbers. X is going to be greater than some number, but less than some other number. So the number on the very left, -2, should be the leftmost part on our graph. We should be starting at -2 because we have a or equal sign here. Our circle should be filled in. Then we just have a less than symbol. So that's not going to be filled in. And it's going to end at the number 4. So we know that we're looking for something kind of like this. A filled in circle on the left, an open circle on the right. It's going to start at -2 and it's going to end at +4. And we can see that answer D matches that description. Filled in circle at -2, a solid line up to 4, and then a hollowed out circle at 4. The most important part of those kind of problems is making sure that the circle type is correct. All right, this is a tricky problem. John needs to replace boards on a 22-foot section of fence. He plans to place boards as shown below. So we can see that his boards are 5.5 inches wide. But his section of fence is being measured in feet. So we have a difference in units there. So we have to be careful about that. This is a great example of a problem where using a little bit of rounding helps. So 5.5 inches is really close to how many feet? It's close to 0.5 feet. It's just about half a foot. So what if we think about the boards as being 0.5 feet, just for estimating purposes? So if we're doing 22 feet of fence and it takes one board to do half a foot, it's going to take two boards to do every foot. So 22 times two boards is 44 boards to finish his fence. Now we know that that's not exactly right because we rounded, but it's going to be pretty close to the right answer. And the right answer in this case is 48. So that's a way that you could answer that question without dealing with 5.5 inches and figuring out exactly how many boards. We use just a little bit of estimation. It clearly is the closest answer, and we give that answer and we move on. This question was actually in a practice test in the no calculator section, which makes it even more important that you use estimation. A parallelogram has two obtuse angles and two acute angles. If the measure of one of the obtuse angles is 110 degrees, what is the measure of one of the acute angles? Now, we have covered parallelograms. We probably did not talk about the angles in those terms. So let's make sure that we understand what those terms mean. Acute, you can translate to the word sharp. Acute equals sharp or pointy. And obtuse, kind of the opposite of that, maybe big or fat angle might be a way to think about that. So when you look at a parallelogram, it kind of makes sense. And my parallelogram isn't perfect there, but hopefully you get the idea. So we have two obtuse angles here, and we have two acute angles, two sharper angles, and that will always happen with a parallelogram. So the obtuse angles are 110, and we know that those are the same. All we need to do is use the method that we've used before to figure out what those other angles are. So we know that there's 360 degrees in this whole shape. So we take 360 and we subtract 220 because there are 220 degrees between those two. That leaves us with 140, and then we divide that by 2, and that will give us our other two angles. The other two angles must be 70. So we have 110 and we have 70. I'd like to also point out a tip that I may not have given in class. You may have noticed this actually, that the adjacent angles in a parallelogram add up to 180. 70 and 110 add up to 180. 70 and 10 add up to 180. We could even do it the other way. And it's the same thing. Adjacent just means the angles next door. Those will always add up to 180. It's a good way to check your work. This is a volume problem. Normally, volume problems have a picture of a shape, but this one's unique. Each face of cabinet number 413S is in the shape of a rectangle. What is the volume of model 413S in cubic feet? So what they're telling us here is that the front of our cabinet looks like this. Not a perfect rectangle, but not terrible. And then it is a box. So we want to imagine it kind of looks like this. If the front is a rectangle shape, then the cabinet is going to be a box shape. So if you remember, For simple box shapes, all we need to do is to take the product of the dimensions of the shape. There is one twist here, though. Our dimensions are in inches, and they're asking for the answer in cubic feet. You always want to be aware of that. So we're going to need to convert all of our dimensions into feet, and then we can multiply. Fortunately, that conversion is pretty easy. We just divide the inches by 12. 24 divided by 12. So this is in inches, and this is in feet. 24 divided by 12 is 2. 72 divided by 12 is 6. And 18 divided by 2, or by 12, I mean, is 1.5. We divide each of the dimensions in inches by 12. We get the dimensions in feet, and then we just multiply. So 2 times 6 times 1.5. What is that? Go ahead, do that in your calculator. 6 times 2 times 1.5. That is 18. And because we have multiplied feet by feet by feet, we get cubic feet. And there is our answer, A, 18 cubic feet. Checking my notes here as we move along. Some questions will ask you to remove a coordinate pair. Sorry, I didn't mean to advance that. To make a function. What does that mean? Well, there is a definition of a function that says we cannot have two values for y for a given value for x. So let's start out with some of these points here. When x is -2, y is -4. That's okay. There's only one answer. When x is 0, y is 0. That's okay. When x is 1, is y 2 or is it 3? We can't have that. So let's keep going, though. When x is 3, y is 4. When x is 5, y is 4. That's okay. But this is a problem because we have one input and we have two outputs. So we really don't know whether the answer is 2 or 3. So in a question like this, you will need to remove one of these points. And the way the question will be written, only one of them will be available to be removed. So, for example, the answers to this question might be -2, -4, 1, 2, 3, 4, or 5, 4. And you would want to select 1, 2 because it's one of these points that's stacked on top of each other. They don't even have to be right next to each other. Even if it was up here, it would still be a problem. We do not want any points with the same value of x and multiple values of y. So this would be the point that we would remove. If 1, 3 had been in the list, then that would have been our choice. It's just that one of those has to go in order to make this a function. I know that might be a little bit confusing. We didn't really talk about that, but I wanted you to see that problem type before you see it on a test. Here's something else that we did not do. Multiply and express the product in scientific notation. So we didn't do any multiplication of scientific notation. What I would encourage you to do in this problem, and I know that this will work on your TI-30XS calculator, is use your skills to convert this into standard notation. So we're going to start out by converting 4.5 times 10 to the 7th into standard notation. So we need to move the decimal 7 places. 1, 2, 3, 4, 5, 6, 7. So we add the zeros here. And then it's always a good idea to add the commas so that you can kind of see what that number is. That's 45 million, 45 and 6 zeros. The other number's a little bit easier. 3.2, we're going to move that 4 places. 1, 2, 3, 4. We'll add 3 zeros. That is 32,000. Grab your calculators and multiply those two numbers, and you will get the correct answer to this question. I'm going to do it right now. I did it before, but I'm going to do it again. 45 million times 32,000. And notice that you get scientific notation in your calculator. And that's because your calculator cannot process that big of a number. So it turns it into scientific notation, and you should get that. Now, if it doesn't, and you just get a really big number on your screen, then you will need to convert it back to scientific notation. But I think that's the easiest way to handle this problem. There are some others, but I think it's the most straightforward. The bar chart shows the top 6 pharmaceutical companies in the United States and their annual sales figures for recent years. If BMY, let's focus on the ones that they're talking about, BMY had a 6.3%, I'm going to note that down here, share of the total pharmaceutical sales. What percentage of the total sales did J&J have? So we're talking about the first one and the last one, and we're trying to figure out what percent that is. Well, the key here is that if we take the ratio of the sales, J&J over BMY, what kind of a number do we get? We get 6,897,000 divided by 18,808. Those are all in millions, I think. So we just divide those numbers. 6,897 divided by 18,808. And we get the number 3.29 approximately. What's the meaning of that number? That number means that J&J's sales were 3.2 times as much as BMY's. It follows then that we can multiply BMY's percent by the same number, and we will get the percent for J&J. J&J's percent should be 3.29 times BMY's number. So 3.29 times 6.3. Go ahead and do that. What did you get? 20.7. And that lines up with answer A. 20.7. Makes sense. They had 3 times as much sales. They should have 3 times as large a percent of the total. So figure out that ratio of the sales first and then apply it to the 6. I should have put a percent symbol here and a percent symbol there. This next question, how many different passcodes can be formed by the letters A, B, C, and D if each letter can only be used once? This is a permutation question. So we can think of this like we did with the multiplication. If we pick one of these letters and we put it in the first place, how many different choices of letters do we have? 1, 2, 3, 4. There are 4 possible letters for the first. Now that we've chosen that, for the second position, there are only 3 letters to choose. After we choose that one, there are 2 left, and after that, there is only 1 left. And if we multiply those, we will get the answer to this question. 4 times 3 times 2 times 1 is 24. And we could do this with our PRB key. We are selecting from 4 letters. This is a permutation. The order of these letters matters in a passcode. And we are going to select all 4. We didn't do that very often, if at all, where we were selecting all of the possible ones. So for NPR, 4, NPR, 4 also gives us 24. So just a reminder that there are 2 ways to arrive at the answer to a permutation problem. We can do this count down and multiply approach, or we can use our PRB key. If 150% of a number is 75, what is 90% of that number? This is the kind of percent problem that might make your head spin. The tricky part is that it really requires 2 steps. So let's first focus on this. 150% of a number is 75. Let's find out what that number is. And our percent formula says 150 over 100 is going to be equal to is 75. So 75 goes in the is position. And of is what we're trying to find, of a number. So we put an X down here. And then we cross multiply. And we're going to solve this, and we're going to figure out what our number is. So 150x is equal to 7,500. And then we divide both sides by 150. 7,500 divided by 150, x is equal to 50. But we're not done. We just found what the number is. Let's look at the next half. What is 90% of that number? So we could use the percent formula again. 90%, our 50 now goes on the bottom of that number. That's why we put the 50. What is, we put our x on top. And we cross multiply again. X times 100, 100x. 50 times 90, 4,500. And then we divide both sides by 100. X equals 45. That's the answer to this question. For this second part, we could have taken that little bit of shortcut. When we get this question, what is 90% of that number? We have turned the 90% into a decimal, and we have multiplied by that number. So 0.9 times 50 is also equal to 45. So that is an acceptable way to kind of finish that problem. But the important thing is that we first need to figure out what the number is, and then we can find out what 90% of that number is. All right, I hope that was a helpful review of some unique problems. If that went too quick for you, feel free to watch it again, slow it down, pause it, try to work out some of those numbers on your own. But I just wanted you to see some of those unique problems in this format before you see them on a test.